Interconverting hydronium hydroxide concentration at 25 degrees Celsius. So, what helps you understand this kind of question is understanding that there is a relationship between concentration of hydroxide and concentration of hydronium in an aqueous solution. And where this actually comes from is the autoionization of water. Autoionization means when something can ionize itself. So water, as you know, is amphiprotic. It can act as both a Bronsted-Lowry acid and a Bronsted-Lowry base. So let's imagine that this first water is a Bronsted-Lowry acid. It's going to donate its proton to its buddy next door. So what do you have left from water after it's donated a proton? You'll have its conjugate base. So the conjugate base left behind will just be one hydrogen, one oxygen, which is OH. Capital letters, please. Um, and then if we've lost an H plus, we have to take one off the charge. So that is our buddy, the hydroxide ion. Okay. And then if we imagine the second water molecule has absorbed that proton. So what do we get if we add an H plus to the formula of water? We get H3O, and that'll be a cation plus because of the H plus charge, and that is aqueous. So this is an expression for the autoionization of water. And if we're going to write an equilibrium constant expression for that, well, we can do that. But remember the rules of heterogeneous equilibria, okay? Water is in the liquid state, so won't appear in the equilibrium constant expression. So K equals the concentration of hydroxide times the concentration of hydronium will equal a number. And actually, in a solution of water, the concentration of hydronium ions is about 1 times 10 to the minus 7, and hydroxide ions is 1 times 10 to the minus 7. So that gives us a total of 1 times 10 to the minus 14 if you add those two together. So that is what's called the ionic product for water. So we give our equilibrium constant K a little subscript W to represent the ionic product for water. Just the same as Ka for an acid dissociation, the A means acid. Kb for a base dissociation is B for base, right? Very on the nose. Okay, so we can use this now to calculate the concentration of hydroxide from the concentration of hydronium or vice versa. So we've been asked to calculate the hydroxide concentration, so we can just rearrange this. So hydroxide concentration is going to be the subject. So the hydroxide concentration is going to be Kw over the hydronium concentration. So Kw is always going to be 1 times 10 to the minus 14. Again, you might want to be careful with like parentheses, etc., sticking that in your calculator. In terms of sig figs, I mean, we always write 1.00 times 10 to the 14. Technically, the units would be molarity squared, so they can cancel out appropriately and give us molarity for our concentration of hydroxide. But what I'm trying to get at is it's not going to affect the sig figs of your answer. Give the sig figs of your answer based on the sig figs for your hydronium ion concentration in this case. So 1 times 10 to the power of minus 14. Technically, that's going to be molarity. Oh, hello. Don't do that. Undo. Really? We're not doing that. Okay. Oh, what did you do? I don't know. I don't want this. Go away. Hang on. Give me my cursor back. I don't know what this is, but I don't want it. Go away. And that'll be technically molarity squared. What a pain in the boo. And then divide that by, might as well do that line while I'm here, the concentration of hydronium, which is going to come from the question, which is 0.018 molarity. So molarity squared divided by molarity is just going to give me molarity. That's what I want. So I end up with a concentration of hydronium of 5.6 times 10 to the power of minus 13 molarity. Okay, so the product of your concentration of hydronium ion concentration times the concentration of hydroxide is always going to equal 1 times 10 to the minus 14, right? There's an inverse relationship, right? As the concentration of hydroxide goes up, the concentration of hydronium goes down, and vice versa. Okay, so you've got like an inverse proportionality there. Okay, so hopefully that is helpful for you guys.